Science.
We're on a research expedition between the Zimbabwe and Zambian border. In many ways, the rivers on the African continent remain a mystery. Today, European scientists joined forces with their African colleagues in search of answers on the role played by African rivers in the global climate.
Rivers naturally produce CO2, which contributes to global warming. Land use and vegetation patterns along the riverside influence this biochemistry. An international research project aims to improve our understanding of how the rivers in Africa work.
We're on the Zambezi River, the fourth largest river in Africa and the first largest river flowing into the Indian Ocean. And this is our study site.
Unlike the European fluvial systems that are relatively well researched, rivers in Africa have so far been poorly studied. A greater understanding would help countries like Zambia manage its water resources, responding more efficiently to growing demand.
The population of the country has increased. There is also an increase in the economic aspect, meaning mining and other users, agriculture, electricity, and therefore it's important to study, to know how much water we have, so that all these competing users could have a share of what they want.
Scientists measure various water parameters, including its temperature and CO2 content. This data will explain how most of the carbon entering the river with decomposed organic matter or soil minerals gets converted into gas or sediment, never reaching the ocean.
At this point, everything is more or less unknown. This is why we are here, but we're trying to look at the transport of carbon to the ocean, of sedimentation processes, the fluxes to the atmosphere. We're looking at the source of carbon. We try to understand how much carbon on those rivers. Is it terrestrial, and how much is it aquatic produce?
When the series of measurements on the Zambezi River are complete, Christian will return to his home university in Leuven, Belgium. By that time, his assistant Frank, a master student at the University of Zambia, will have learned all the methods to make sure the research will continue after this project is officially over.
The methods of sampling are not as easy as one would think, so they are very precise, and I've been very, very keen to follow and learn throughout the master project, and I think that is also adding to what is called capacity building.
The water samples collected in Zambia are being sent to laboratories in Europe for more detailed analysis. Similar field studies also take place in Kenya, Mozambique, Niger, Gabon, Madagascar, and the Congo River Basin. Measurements are taken at regular intervals along the whole length of Africa's main rivers.
We expect that the geochemical parameters, including carbon dioxide and the oxygen, might change along the river stretch, influenced by landscape, by the hydrology. This is why we continue sampling the river downstream, down to the Indian Ocean, with a large number of sampling sites.
Studying the secrets of African rivers will shed new light on biochemical mechanisms shaping the global climate, helping to secure a safer future for the people on the continent.